Hello everyone. In today's tutorial, we want to consider this topic known as binomial theorem. Binomial theorem. If you look at the word binomial, it is from the word two. And anything that has to do with bi means what? Two. What about one? One means monomial. What about three? Three means tri. However, in today's tutorial, we will only be dealing with bi, which is two. Now, what do we do under binomial theorem? We are simply looking at expansion of terms with a certain power. Expansion of terms with a what? Certain power. In which, in the brackets, the terms we want to expand are just what? Two. That is the meaning of binomial. That means expansion of terms in the brackets that are no more than two to a certain power. Of course, if I say x plus y raised to power 0, everyone knows that any number raised to power 0 is what? 1. So here we will get 1. Okay, let us proceed. If I have x plus y raised to power 1, of course, this will also give us x plus y. Observe that the coefficients of the binomial terms in the brackets are both what? 1 and what? 1. So the power has what? Increased from 0 to 1. Okay, let's consider this. X plus y all raised to power 2. Of course, x plus y raised to power 2 means x plus y multiplied by x plus y. And this will give us x squared plus 2xy plus y squared. What can you notice here? The coefficient of x here is what? X squared is 1. The coefficient of xy is 2. And the coefficient of y squared is what? 1. Okay, let us increase this problem a bit. We have x plus y raised to power 3. Don't forget we are looking at binomial. And binomial simply means two terms in the bracket raised to a certain power. So here the power is 0, 1, 2, 3. So here, this also means x plus y, and what? X plus y. It means x plus y in 3 places. Of course, x plus y and x plus y. This will give what? X squared plus 2xy plus what? Y squared. Then multiply it by what? By the remaining x plus 1. So if you do this, see what you are going to get. You will get s cubed plus 2x squared y plus 3x squared y plus 3xy squared, then plus what? Y raised to power 3. So if you multiply this by this is what you're going to get. Now, the major reason why we are doing this is because we want to know the fastest way to expand binomial terms in higher powers. And that's why I'm taking it one by one. Okay, now let us also observe the pattern of the words of the coefficients. You have here 1, you have 3, you have 3, and you also have what here? 1. So if I write out the triangle, if I write out the coefficients of the variables in the expansion out, when the power is 0, I have what here? 1. Okay? When the power of the binomial is 1, the coefficients are what? 1 and what? 1. Okay? When the power of the binomial is 2, the coefficients are what? 1, 2, and what? 1. Okay? For the power of 3, what is the coefficient? We have 1. Coefficient of the variables. We have 3. We have 3. And we have 1. All right. I will stop here. Now, this triangle on the board, it looks like a triangle. This is what we call Pascal triangle. All right. So I may not need to expand in this form. If I can understand how to continue this pattern here, it will make expansion of binomial words expression to be what? Easier. How do I mean? Now, each of the pattern here of the power, this is for x plus y raised to power 0. This is for what? x plus y raised to power 1, and so on and so forth. It means that for me to get the next coefficient of the what expansion of the expression rather, or after you have expanded, what I just need to do is I'll just put 1 here, I'll put 1 here, then I'll add this and this together. 1 plus 3, I'll get 4. 3 plus 3, I'll get 6. 3 plus 1, I'll get what? 4. And this one is for x plus y raised to power 4. So in the next video, I will show you the full diagram of Pascal triangle. And we use Pascal triangle to fix in the coefficient of what? Binomial expansion. All right, thank you. Bye.